Hi, welcome to Slay the PE's Mechanical Engineering PE exam review videos. This video is Mass Balances 1. It's just one of many review videos in the Energy and Power Systems module. Okay, let's get started with mass balances. But before we even talk about mass balances, we have to define some fundamental quantities. What we see here is an illustration of a pipe with a diameter d and a circular cross-section. So the quantities that we need to define or discuss are the volume flow rate, which we denote with a V dot, and the mass flow rate, which we denote with M dot. The volume flow rate is given by the cross-sectional area times the average fluid velocity inside the pipe. And it's interpreted as the volume of fluid that pierces the cross-section of the pipe per unit time. Okay, so therefore its units are typically specified in volume per unit time, of course. So you'd see something like cubic feet per hour, or liter per second, or gallon per minute, okay, or cubic meter per hour, or the CFM, cubic feet per minute. That's a unit that the HVAC folks should be quite familiar with. Also, depending on the field, you might be familiar with something like barrels per day, etc. So the point is that that's volume per unit time. The associated concept of the mass flow rate, m dot, is simply the density, right, rho, times that volume flow rate. So it gives you the mass that crosses the cross-section of the pipe per unit time. Therefore, its units are typically, kilogram per hour, or pound mass per hour, anything that is a mass and then a time unit in the denominator. All right, so that's mass flow rate and volume flow rate. And then there's this important relationship between mass flow rate and average fluid velocity. This is one of the equations that is really worth memorizing for the exam. The mass flow rate is the density times the cross-sectional area times the average fluid velocity, V. You might be wondering why I'm saying average fluid velocity, and this is a little bit of a side note, but perhaps you remember from school in fluid mechanics, when you have flow inside a pipe, there's actually a velocity distribution. Okay, so the fluid particles that are near or at the wall, they're stuck there, they're stagnant, they have a zero velocity, whereas the fastest moving fluid, it tends to be around the center of the pipe. So it's actually a distribution. But that's really too complicated for and beyond the scope of the PE exam. For us, it'll be more than enough to always think about an average velocity. That's this profile averaged over the cross section, so it's constant. All right. So having said that, let's look at an example, and that's the approach we take here at Slay the PE is examples right away. Because that's the best way to assimilate concepts or bring them back from wherever you had them stored. Okay, so let's look at this example. At this point, you are free to pause the video and attempt a problem on your own. And if you're not inclined to do that, you can just let the playback continue and we will solve it here in real time together. Okay, so we have a pipe with an inner diameter of 7.98 inches and the volume flow rate is 650 gallons per minute. They're asking for the velocity inside the pipe, right? The average fluid velocity inside the pipe. Okay, well, from the equations that we just discussed, it looks like we're going to use this one, right? Because we have the volume flow rate and we can calculate the area, so we can solve for the velocity. So this is a straightforward application of one equation, and you'll be surprised how common this type of problem is in the PE exam, where you just one equation, substitute, and you're done. All right, so the average fluid velocity is the volume flow rate divided by the cross-sectional area. Okay, so if we plug in the quantities that we have 650 gallons per minute, and an area, we could have calculated it separately and put in an area here, or just put in the equation for the area, pi divided by 4 times 7.98 inches, and that quantity squared. Now, there are a lot of people that have a really bad habit of writing down numbers and not writing the units next to them. So somebody would write the 650 and not write gallon per minute next to it, or 7.98 and not write the inch next to it. So, you imagine their piece of paper, it says 650 divided by pi over 4 and 7.98 squared. And if you punch that into the calculator, you're going to get an answer, right? But the units are going to be something weird, gallon per minute per square inch. But anyway, if you process those numbers in the calculator, you're going to get 13. And notice, that's one of the answer choices. And this is a typical pitfall or trap, quote unquote, that you'll see in the PE exam. You'll get something that looks right if you're not careful, right? Because they're specifically asking for the velocity in feet per second. Okay, so we're not done yet. So I just wanted to spend a little bit of time on that, because that is probably one of the biggest obstacles to success in the PE exam, is not knowing or not being aware of how careful you have to be when working with the units in the test. So the approach to units that we recommend here is the use of unit conversion factors. And what those are is just, we like to say it's a fancy way of rewriting the number 1, but you have to do it in a clever way. So one thing to do is to use the unit conversion factor, that 1 cubic foot, right, is 7.48 gallons. So this is why I say that this is a fancy or smart way to write the number 1. I just, between these vertical lines, wrote a ratio of two things that are the same. So that's 1, right? When two things are the same and you divide them, you get unity. And when you multiply anything times unity, you don't change it. So the presence of this unit conversion factor doesn't change anything in my equation. But it allows me to get rid of these gallons, the way I've written that number 1. And so you're going to keep doing that until you have what you need. The other unit conversion factor I would use is 1 minute divided by 60 seconds. Okay, so that way I get rid of these minutes. So now I have cubic feet per second in the numerator. So if I convert these inches squared to feet squared, then I would have feet per second. So the unit conversion factor I need to use here is 1 foot divided by 12 inches. And the unit conversion factor can be squared, right? So I have inches squared. Or you could have written 1 foot squared divided by 144 square inches. It's the same thing. But if this is the number 1 and you square it, you also get the number 1. All right, so then now you can process all these numbers, put it in the calculator, and you're going to get 4.17 feet per second. So in this case, we see the correct answer is B. So that marks the end of Mass Balances 1. If you're comfortable with the material, you can move on to Mass Balances 2. In that video, we will continue with examples to review these equations we discussed today.